Okay, we're going to go ahead and get started. Thank you everyone for coming, the Windows Azure overview talk. My name is Scott Guthrie. I help run Windows Azure, and I'm going to spend the next hour kind of walking you through a little bit in terms of what Azure provides. Now, for people that watched the keynote here this morning, you probably saw about 90 minutes of Azure demos, and so it's awesome to be able to give an overview talk after that. Cool thing though is you're going to see all new demos here this morning, and so I'm trying to make sure no demo that we showed this morning in the keynote you're going to see here in the overview talk. So I'm going to focus on a different set of features or exercise things in slightly different ways, so you hopefully still get a very fresh new experience. So there's a couple cool things if you're watching online that are in Windows Azure that I normally would talk about. Make sure you watch the keynote as well as this talk, and you'll be able to see kind of the full spectrum of all of it. So, kind of what is Windows Azure at a high level? It's Microsoft's cloud computing platform. It provides a really flexible environment. I hope you saw that in the keynote demos this morning. Whether you're targeting Windows 8 devices or mobile clients, whether you're building web applications, whether you're doing media, whether you're doing enterprise apps, whether you're doing data mining, we kind of have lots of features and capabilities you can take advantage of across the spectrum. It's designed to be kind of open. You're going to, in terms of what operating systems you use, what devices you target, and from a programming model and from a protocol perspective, we've also spent a lot of time making sure that we embrace open protocols wherever possible. And again, you'll see that sprinkled throughout my demos here today as well. And it's designed to be solid so that you can bet your business on it. And it also provides you the global reach so that you can actually deliver the solutions as close to your customers as possible. And so just talking a little bit about that reach, we actually have Azure spread out across the world. And this is sort of difficult to see, perhaps, but the dark circles indicate what we call regions where you can deploy your applications. The light circles indicate CDN endpoints where we can edge cache your content. But effectively, we have today 8 regions that you can deploy applications in within Windows Azure, 4 in North America, 2 in Europe, and 2 in Asia. And again, the beauty, and you're going to see this footprint expand rapidly over the next 2 years. And again, the benefit here is every application you build with Windows Azure, when you go to deploy it, you can choose wherever you want to deploy it in the world. And we spend a lot of time making sure that you have a very consistent deployment experience, the exact same programming model, the exact same features everywhere. And it gives you kind of the ability to do global reach. In addition to kind of deploying your app in just one part of the world, you can also deploy the app in multiple parts of the world. And then use traffic management capabilities so that you route the users closest to the instance of your app that's running. Again, allows you to have an even better experience that you can deliver to customers. So I kind of showed we have lots of data centers around the world. One question people often ask is, so what actually happens inside the data center? When I was doing the keynote demo this morning and we said, deploy something, did some guy in Iraq push a machine in and power it on? No, our data centers are actually lights out environments. Meaning that we don't actually have many people inside them. I think we average about 5,000 servers for every one person inside the data center. And they're fully automated, which means basically you as developers, when you want to go ahead and stand something up, you send REST calls to us, and we take care of the rest, and we can spin up a lot of instances very, very fast, or give you a lot of storage very, very fast. And I thought I'd actually show just what one of these lights out environments looks like, so you can get a sense of what's happening under the covers. So this is a video of our Chicago region. And so our data centers here basically lights out, full of containers, racked with thousands of machines. We only hire really strong people on the team. So this is an example of us bringing a container in. We don't do that on a daily basis. But basically, as we need more capacity, we plug it in. We add basically electricity and water and cooling. And basically from that point on, that machine is running by itself. And then you as a developer can basically do anything you want on it. And the way that kind of Azure works, and you'll see this kind of throughout the demos, is again providing kind of this automated environment where you can control everything yourself, whether through our admin console, which you saw a lot of this morning in the keynote, or through REST calls that you fire, so you can script it and automate it from the command line or from within your application. And then basically you can do pretty much anything with it. Cool thing about Azure that's very different from kind of a lot of environments that you might be used to in the past, where you stand up infrastructure and you need to have to pay licenses up front, or you got to buy machines up front, or you got to get a bunch of things approved up front, is that Azure kind of offers a model where you pay only for what you use. And so that basically gives you the ability where if you're not using something, you can turn it off and the price stops. If you need a lot of resources quickly, you can spin them up, and then when you're done, you can spin them down, and you're only paying for the hours that you're actually using them. And so it's something that's kind of provides both a lot of power and a lot of flexibility with your workloads. Again, we'll talk on that briefly throughout the day in terms of some of those kind of capabilities. But for like an event like Build, for example, we can spin up a lot of Azure Media Services and take advantage of that. After the event's over, we need a lot less, and we can spin them down. And again, the beauty of only paying for what you use is it makes it also very economically viable for a bunch of projects that today, if you had to buy all the resources up front, you just couldn't get approved. So let's drive into some features. And again, I'm going to focus on the features we didn't cover in the keynote and only show demos that we didn't show in the keynote, so you can get a sense of kind of all the other things around Windows Azure that we provide and learn a little bit more about them. First one here that we didn't talk about this morning, but it's a cool new feature that we're introducing this year. It's something we call virtual machines. This is something that historically Azure didn't have support for, and that we're kind of introduced this past summer. It's in preview form today, and we're working hard to kind of ship it. And it basically allows you to run durable virtual machine workloads in the cloud. And you can do it with both Windows Server as well as Linux. You basically have very flexible workload support. You can run pretty much anything you want on these machines. You are admin on these machines. If you reboot the machines, whatever you put on there will still be there. And we also support virtual private networking capabilities so that you can very easily stand up your own virtual private network to join the machines across together. That's private just to your application. We also support the ability for you to very easily create a virtual private network that can connect your apps running in the cloud with your on-premise environments. So if you already have, for example, a VPN set up in your organization, you can very easily join that network with Windows Azure in a secure way and basically isolate your workload across it. And so let's go ahead and see some demos of this in action. So this is kind of the Windows Azure portal that you saw a lot of earlier here this morning. One of the things you can do in the portal is create new things. So you just click the new button. You saw websites, and you saw us create mobile services this morning. Let's go ahead now and create, let's say, a virtual machine. What would you like to call it? Godzilla. Okay. It's always interesting when you ask that. Let's see. Did anyone pick? Oh, no one's taking Godzilla, so you're in luck. One of the things you can do when you define this app is you can pick what image you want to use. We support a variety of different images. You'll notice we support both Windows Server as well as Linux images. In fact, we love Linux so much, for some reason, we actually have a Linux instance first in the list. I noticed that last night. That might not be first in the list next week, but it is today. And so you can easily pick from your image. You can pick what size machine you want to deploy it. So you can go, an extra small instance starts at about, I think it's $0.0125 per hour. So it's about 9 cents or $9 per month. And then we have large instances which have more cores and more memory. And then basically you can give a password. You can choose where in the world you want to run it, and that's called a region. And so I can run the East US, I can run the West US. I'm going to pick West US here, and then just hit create. Basically, that's all that's necessary in order to start provisioning a new virtual machine. And that'll take just a few minutes to stand up, at which point I can log in using the password that I set, and I'm a full administrator on the machine. And so just to give you an example of one virtual machine that I actually use. I have a blog, and it's actually running right now in a virtual machine on Windows Azure. So if I drill into it here, this is one I created earlier. You can see a bunch of statistics in terms of how much traffic. I'm doing 70 megabytes per second, apparently, running on that VM. You can notice here how many cores I'm using in my subscription. And if I want to, I can go ahead and connect to it. And when I do, this is running in the East region of the US. bam, I'm now logged in as an administrator on my machine. And so I have full admin access, and right now I just have IIS stood up, and I'm hosting my site on top of it. And I need to activate my window, activate my copy, but apparently. Cool thing about the virtual machine support, you saw how easy it is to create. You can attach multiple drives to this machine, and again, it's all virtualized, so we're not actually really plugging in hardware. But effectively, I can go ahead here and just say attach a new empty disk to the machine. I can choose the size in gigabytes that I want to attach. You only pay for what you use. So, in fact, if you actually attach a drive and don't save data on it, we won't charge you. It's only when you actually save data on it that we'll charge you. You can notice here I've got both an OS drive and then a data disk that I've actually attached to this machine. And if you go into the machine here, you'll notice there's my F volume. And this is that data disk that I've attached, which is separate from my OS partition. And I can basically stick anything I want inside there. Again, all the software that you'd expect to have work just works. And again, I'm full admin on the box, and so I can do anything I want as part of that. A couple of cool things that we support, or a couple of things to call out. One is we have a notion of endpoints that we expose on the web. So by default, we lock down the machine. You can go ahead and choose which ports you want to open up to the world. You can also click the Configure tab at a later point. And if you want, you can actually size the machine and control, you can basically upsize it to be whatever VM size you want. Other thing to call out in the Configure tab, you'll notice this concept called availability set. I'm not going to go into a lot of detail on it in this talk, but some of the other Windows Azure talks this week will go into more detail on it. But it's a cool feature that basically allows you, if you want to stand up multiple VMs, you can group them into what's called availability sets. So you could have, for example, a web availability set and a database availability set. And you could have multiple machines mapped into them. One cool thing is when you provision any of your virtual machines inside Azure, we'll make sure that all the machines in availability set, or all the virtual machines in availability set, run on separate physical hardware with a separate network and a separate storage system. And the benefit there is if, for example, a machine blows up or a network router explodes, we can basically automatically make sure that you're not going to bring down your entire tier or everything within the availability set. And you can also set up network load balancing rules so we can automatically direct traffic to the surviving instances. And so it gives you kind of a nice way that you can kind of provide some additional resiliency into your app. And the beauty here is you just can declaratively set the availability set, and we'll take care of the rest. So I showed you here how you can do Windows. I showed you in that list how you can also go ahead and create a Linux instance. We have, from our partners that provide Linux instances, Ubuntu, CentOS, as well as SUSE support. And so it's basically just as easy. You just go ahead, click that. You can set your password, and you go create. I have one that is actually already running that I created last night called the Scott Goo Linux instance. And again, you get the same kind of experience. You can see when I logged in last night to test it. Same experience in terms of perf, and I can attach drives just like I can with the Windows instance. When we attach drives, we do it at a device level. So the OS that's running in the virtual machine, it looks just like a device. And so on Windows, you could format it with NTFS. On Linux, you could format it with your file system of choice there as well. And then here I got an SSH port, and so if I want to, I could just say SSH scottgoolinux.cloudapp.net. What was my admin password? It was not that. I'm logged in now to an Ubuntu instance running in Windows Azure. I can see all the standard stuff, and here's the top on the machine. Just, I know you're probably tired of seeing lots of Linux demos at our event this week, but this is one that we do support. So anyway, this is a cool example. Again, you can run anything in these things. And this kind of goes back to the open thing I talked about at the beginning, where if you want to run Linux, if you want to run Windows, if you want to run SQL, SharePoint, you want to run MongoDB, you can basically choose whatever workload you want. You can customize it however you want, and it gives you kind of ultimate flexibility to use anything within an Azure environment. So it's a little bit in terms of the overall virtual machine experience. Again, if you want to create a network, you can just click Networks, and you can stand up a virtual network really easily. As part of this week's update, we now allow you to stand up what's called a virtual network. So I could just say my virtual network here. And this gives you a private address space that's scoped to your applications. And so you can provide your own address space, or you can just use the default that we provide. And one benefit here is that allows your machines to talk to each other without going over the public internet. And so you can actually group multiple machines together, and they can do direct IP traversal back and forth, again, in a very secure way, so that you don't have to open up, for example, your SQL database to the internet. You can use a virtual private network, only have your web tier open, and then use the virtual private network connect to it. So a little bit more advanced feature. More talks later on this week that'll go into detail on it, but a kind of a pretty powerful feature you can take advantage of. So let's talk a little bit about what's happening under the covers with Windows Azure when we're doing this. And this is sort of questions people often ask, and a couple things I want to highlight. One is, how are we actually persisting these VMs, and what format are we using? The cool thing is we're using the same VHD format that you get with Windows 8 as well as Windows Server 2012's Hyper-V based system. And so if you, on your dev machine, create a VHD, you can actually upload it into the cloud and boot it up inside Azure. Likewise, you can go ahead and so basically just literally copy it up. There's no import-export process. You literally just copy it, and then within the portal you can just say start a VM based on this VHD. Likewise, any of the VMs that you create in Azure, you can download and boot up on your local servers or local desktop. Again, you just copy it down, start it up, and it's just a VHD. That's true both for your OS partitions. It's also true for your data disks. So it's a great way to actually upload and download data as well. Just create a VHD and you can mount it in either way. The other cool thing is it means that if you have an existing hosting environment that you're working with or that you want to be able to support, you can also take our VHDs and you can, the running Windows, you can boot it up. Again, this sort of gives you lots of flexibility and helps make sure that as developers, you kind of have no lock-in in terms of where your environment can overall run. Other cool thing about the way our VHDs work is instead of kind of running them on local disks, we're actually backing them with what we call the Windows Azure storage system. And basically the way the storage system works is it's a cluster of machines that we virtualize to make it look like a single storage thing that you can go ahead and mount and use. And so when you built, for example, attach that data disk like I did earlier, it's not actually going into the local drive. It's not even going into a single remote drive. Instead, it's going into our storage system, which is backing it with multiple physical drives. And the beauty about this is we're automatically load balancing the traffic across them, so we can give you kind of consistent read and write throughput. We'll also monitor the drive. So if a drive goes bad, we've automatically partitioned your data so it's on multiple drive disks. And we can automatically avoid any download, and we'll even actually rehydrate another copy from the other ones to make sure that you don't have any interruption of service. So it basically gives you kind of a very reliable, always-on experience. Other cool thing that we do is we automatically, on our storage system, geo-replicate in a continuous way all the data that you store in our storage environment. And what this means is, and we basically guarantee within about 15 minutes, your data is backed up somewhere else, at least 500 miles away, if you write it through our storage system. And so that's true for VMs as well as anything written to storage. And so in the event of, let's say, a hurricane that impacted, say, your east region, you can know that even in a worst-case environment where a data center was completely lost, that you have another copy of it somewhere else 500 miles away. Now, this is true for, again, anything stored in VHDs and storage. There are some services that we provide higher level. We don't have this continuous geo-replication feature available yet, but kind of our goal with Windows Azure is to enable you kind of consistently across all your services to have this capability, and you can sleep better at night as a result. And just to kind of show off a little bit, one more little demo of kind of how this works is, again, when I go ahead and go into the portal for a particular app, one of the things you'll notice is there's an images folder and a disks folder. And the disks folder on your virtual machine shows me actually all those VHDs that are persisted right now within this particular storage account. So you can see them in the portal. One cool thing is you can actually this is a tool from a third party. It's a free tool called Cloud Explorer. If I actually connect to it, you can see all of my drives exposed with it, again, as individual blobs, as hard drives. And if I wanted to, I could, I'm not going to because they're like a gigabyte each, but if I wanted to, I could basically copy this thing and download it and just save it locally. And likewise, if I had a local VHD, I just copy it into this folder, and it'll start uploading that image into Azure, and I can just go into the portal and boot up off of it. And that just sort of, again, talks a little bit about how we're backing your VHDs in storage, and again, some of the flexibility in terms of portability it provides. So moving on, I'm going to talk a little bit about websites. So websites is a cool feature we've also introduced as part of our summer preview wave, and still in preview. And it basically provides a really easy way for you to create a website on Azure. And the beauty about it is it doesn't require you to stand up a virtual machine, and it kind of provides a fully managed environment. So we're taking care of patching for you, we take care of availability for you. And so it kind of frees you from having to think in a very infrastructure way and allows you to really focus on delivering your app and on your site. And you can deploy in seconds using a variety of approaches. We use web deploy inside VS. You can use FTP, you can use Git, you can use TFS. And it allows you to kind of start for free and easily scale up as your traffic grows. And you probably saw Scott Hanselman earlier in the keynote show off that. And I also, in my demo at the beginning, was showing how you can use that. Again, it provides a really quick and easy way to stand up a website. And then the beauty is you can scale it up however far you want. So let's go ahead and do a demo here. So I created a virtual machine earlier. Let's create a website now. Very similar experience. What would you like to call it? Steven, okay. Sorry, Steven. Someone else already has that website. Steven with a PH. That one is available. We'll create the Steven with a PH website. So we're going to go ahead and create this website right now. One of the things we've done is really try to optimize the perf creation of it. So this is actually created now. I can drill in, and I can actually see the website. Again, you get a kind of consistent UI for what it looks like on the dashboard view. And what Scott Hanselman showed earlier today was how you could go ahead and download a publishing profile. And then just directly within Visual Studio, you can import it, right-click, and deploy any ASP.NET app into it in a matter of seconds. And the cool thing about that deployment, and he showed it a little bit this morning, is it works with both websites, or both web content as well as databases. And so you can automate both. And if you're using Entity Framework, we've also integrated the migration capability that it provides, so that not only can you deploy your website the first time with schema, if you change your schema, like you add or remove data, we can use the migration feature as part of deployment to automatically evolve your schema forward or backwards, all as integrated part of that publishing step. You also probably saw Jason do TFS publishing. So you can set up a continuous delivery model where you could use TFS, you push to TFS, and then they do a build and publish to the website as well as the cloud service. So lots of publishing options. I thought, hey, since you've seen those two demos, let me do another demo. Anyone here using Git? Okay, there are people using Git. We support that as well as FTP. So if you want to enable Git-based publishing with Windows Azure, you just click that link. And that's gone ahead and created for me a Git repository for my Windows Azure account. And that now allows me to very easily push files directly from my dev machine using Git up to Azure to deploy. So if I basically create a project, you just say git init, git add the file, commit it, just add a remote that points to that website, and you can just do a git push Azure master, and that'll automatically deploy that particular file or that site up into the cloud. So pretty easy to do. Has anyone seen that demo? A few people. One person has. Okay. Well, if only one person's seen it, then I'll do it. So let's go ahead and have some fun here. So Steven, I'm just going to call you Steven. So we'll create something here. We'll call it default CSHTML. I can say hello world, like so. I can then basically do git init. I can git add. I can do a git commit. This is hardcore. And then add a remote that points to my Windows Azure website on my local dev machine. And I can then do git push Azure master. Oh! I have to remember my password is the problem. The good news is I only have 3 passwords. Yeah, and that was the one. And one thing you'll notice here, we pushed it. Go back in the portal. Notice it's already live. And so basically it's saying, hey, we just did a deployment. We'll go ahead and hit browse. Pop open a new window. Hello world. And so basically right there, we just did a source control deployment from my local system to the Stephen with PH website that we've gone ahead and hit. And we're starting to enable kind of a continuous integration process as part of it. If I want to show a change, hey, let's go ahead and open that file up again. I can say, hello, the time is, so I'm using just Razor syntax here. You can also build more complex apps than that. Second check-in. So let's go ahead and we're going to open this in the background so you can see what's happening. No magical wires here. And I can say git push Azure master. Remember password 2. Pushing it in the background. Notice the portal picks up the change, and we will be deployed in seconds. And so now if I go ahead here, go back here and hit refresh, time is now that. So that's how easy it is to create a new site. That's how easy it is to go ahead and deploy it using Git or TFS or FTP. And hopefully gives you kind of a sense of also in terms of from an openness perspective, we're trying to embrace lots of different technologies, lots of different approaches. One other thing, anyone here using GitHub? Okay, a few people are using GitHub. So let's do one more quick demo here. Stephen with GitHub. Go ahead and create another site. It should take about 7 seconds. Of course, I've jinxed it then. So we're going to create a new site. There we go. I can enable Git or TFS again with this. And one of the cool things that I can do as part of this is I just showed a scenario where I'm pushing from my local dev machine up using source control into the cloud. You'll notice some of these links down here. I can also set up a continuous deployment model with Codeplex, GitHub, or Bitbucket. And so if I want to do Codeplex here, all I need to do is just click this authorize link. This is going to open up and take me off to GitHub, where I can pick from any of the repos that I currently enlisted in. So I have a simple sample demo there. I can hit OK. And what this is going to do now is, instead of having me deploy directly from my dev machine up, this is now going to set up a relationship with GitHub. So it's going to take GitHub a few seconds to push it to me, where anything I deploy into that public GitHub repository in this case is going to be automatically, GitHub will poke Azure, Azure will pull the changes, and now I've basically just done a deployment, not from my dev machine, but from my GitHub account. And the beauty here then is, so if I click Browse, there's Hello Azure, which is what I had in that initial GitHub repository. If I pull up, say, the GitHub Windows tool here and drill in, this is my local repository here. I could go in and if I pulled up, for example, this thing here, I could say, hello, Azure, through GitHub. Save. I could go ahead now and if I go inside the GitHub client tool, you can see the uncommitted changes. So I'm just going to do it all from GUI this time, and I could say update through GitHub. I can commit it. So this is a local commitment, but I'm connected to a repository in GitHub. And what I'm going to do now is sync it. This is now going to have my local dev machine talk to my GitHub repository and push up this change that I just made and update my actual remote GitHub repository. GitHub's then going to fire a message to Windows Azure basically saying, hey, someone just made a change. And because I've set it up so that GitHub has a relationship with Windows Azure, anytime someone checks into that main branch, and this is GitHub waiting to send me the message, as soon as it sends me a message again, Windows Azure will sync that change. There we go. And it just made it live. Notice the update through GitHub text right below that active deployment, so we even actually pass through the check-ins. And now if I go ahead and hit refresh, or browse, Hello Azure through GitHub comes through. So simple way you can enable continuous deployment. You saw TFS in the keynote this morning. It provides a much richer environment where you can actually do builds and run tests. We also then support both Git as well as GitHub-based environments all as well. Gives you lots of flexibility, and if you ever make a mistake and want to roll back, you basically just click an old deployment, hit redeploy, and you can unwind your change and go back to the previous deployment within Windows Azure automatically. So lots of things you can take advantage of. More talks here that will talk more about continuous deployment throughout the week, but just want to kind of show off a few new quick demos that you haven't seen this morning. So that's a little about websites. Let's talk about some, so let's actually talk about, before I do this, how websites actually run. So if I go back to the portal, we've done a lot of stuff here where I get monitoring support, so I can start to see, 470 requests. A few people in the audience have found it. I get real-time feedback in terms of kind of how that site's executing. Right now I'm running in the free tier, which basically means I'm actually not having to pay for anything in order to host this website. And every Windows Azure customer gets 10 free websites that they can host anywhere in the world. And they're completely for free. If you want to, then you can optionally choose to scale this up to make it a paying site. And basically, the free website gets a bunch of quotas here that you can go ahead and learn more about. If you want to scale it up, though, and get more traffic, I think the free quotas give you about 100,000 requests per day. So it's actually a generous number. If you want to scale it up even further, though, just click the Scale tab on your website. And then as Scott Hanselman showed earlier this morning, you can go to a shared model. This basically is still multi-tenant, and I'll talk more about that in a second. But it's basically like $0.0125 per hour, so it's about $9 per month. Or if you want to, you can pick what we call the reserved model, where we basically guarantee you're the only tenant on the machine. You can choose what size machine you want and how many cores or how many instances of that machine you want to run it on. And then the cool thing is, for example, because I'm cheap, I'm just going to say 1 core. If I want to run this now, I just hit save, hit yes. And what this is going to go ahead and do is, hopefully just in a matter of seconds, scale up this website so that instead of running in a shared multi-tenant world, there, we're done. I'm now running on a dedicated reserved instance, or in fact 2 of them, which is great because it's my own private credit card. I'm now running on 2 dedicated instances that are only for me with 2 gigs of RAM each. And that was how easy it was to create the site, deploy it, and now go from a free tier where I'm paying nothing and scaling it up to a dedicated reserved VM model. And the beauty is, I still deploy the same way. I can still update it the same way. These VMs are automatically patched for me, so I don't actually have to take care of that trivia. And if after this event, I want to economize a little bit more, I just hit the free tier and hit save again, and I downsize. And I'm only paying for the number of instances and the sizes by hour. So literally, this demo would only cost me a few pennies to do if it's only running for an hour. And so this is a great way where if you know you got an event or you know you're going to get a traffic on a specific day, you can scale up your capacity like crazy, and then when it's over, you can scale it down, and you're only paying for what you're using. Last thing I should mention for both VMs as well as websites, you can go ahead and have custom domains, so you can register your own custom domain. It doesn't have to be steven.github.azure.net. I could say scottgu.com. I could do whatever I want to. And we support both CNAME records as well as now A records, which give you the ability to not have to have the www part in front of your domain. We support both of them with both shared and reserved instances on Azure. And just so that I can both show the coolness of scaling down as well as not forget about that and actually get hit by the credit card, I'm just going to scale it back down. I once literally did a demo where I highlighted, you can create hundreds of instances, and did it and walked off stage and forgot, and got that credit card bill next week, and I was like, ooh, yep, okay, let's go fix that. So that's why I try not to do more than 20 instances at a time. So couple of cool things about websites. So I mentioned about the shared instance model. In this free model or in the shared model, you're one of multiple tenants on the machine. We do isolate you across other tenants. But again, this is the free model. Nice thing on the reserved model, oops, I'll show the animation there. When I did that reserved scale up, we basically gave you a machine by yourself, migrated all your traffic to it, and then here you're the only person on that machine. And you can then run multiple instances of them like I did, and the scale up only takes about 10, 15 seconds in order to do that. So that's kind of under the covers what's happening. Cool thing also is you can run multiple of your own apps within those reserved instances as well. So you don't need to actually have a separate reserved instance per app. You can actually have multiple of your own apps where you know only your code is running in that machine, and you can support that model as well. So it's great if you're building sites for many people, or you got to maintain multiple sites. You want to make sure I'm the only one there, but I don't want to necessarily have a dedicated one per site. Mobile services, so that was a little bit about web. Mobile services is another feature that we've kind of released this summer. It's also in preview. Josh showed a great demo this morning about it. It basically makes it really easy to build cloud backends for your mobile devices. And we support Windows 8. We support Windows Phone 8 as of this morning. And we also support iOS. And it basically gives you a nice way that you can go ahead and stand up a backend that you can program against from any of those devices. We support a variety of capabilities built in, including data support, so you can store and retrieve data in a secure way. Identity services, like Josh showed this morning, where you can use Microsoft IDs, Facebook, Twitter, Google IDs in order to authenticate. And we also support the ability to run custom scripts, also as kind of Josh mentioned, which means you can reach out to other services on the internet. You can also fire push notifications back to those client devices. So it provides a pretty sweet way that you can go ahead and build backends. One of the things we've really tried to make sure we nail with this is if you're not a server-side guy, if the idea of having to write server-side code and building your own web APIs or your own OAuth tokens is scary, mobile services basically makes it really easy and turnkey, but at the same time gives you an entry point into Azure so that you can extend it with even more power later on. And definitely recommend checking it out. Since Josh did a great demo this morning, I'm not going to do another demo here, but he's got a great breakout talk this afternoon that's definitely worth attending. Last kind of compute model I just want to talk briefly about is called cloud services. So we talked about VMs, which give you your own machine where you can put anything you want on it. We talked about websites and mobile services, which are kind of managed programming models designed for building web apps and mobile apps. Cloud services is kind of the grandfather of them all in terms of capabilities. And it basically provides a managed experience for deploying apps, or what we call platform as a service-based model, that lets you pretty much build anything. So you can build both UI, both mobile and web, but you could also build non-UI. So some of our biggest customers do lots of financial analysis, so it's pure number crunching. But they want to use this cloud service model to spin up and spin down those instances dynamically. And what's nice about it is it allows you to define multiple tiers, like I showed in the keynote. So you can actually group your application into multiple buckets, like a front end and a back end, or multiple middle tiers. And it also supports the ability for you to completely automate the deployment of the system. This differs from, say, VMs that I showed at the beginning of the talk, where when you create a VM, you can pick a VHD template, or you can go ahead and install anything you want in it, but you're very much the administrator of that machine, meaning you have to install the stuff and install patches and things like that. With cloud services, we take a lot of that details, handle a lot of those details for you. So you don't have to install patches, you don't have to install your own custom packages. We give you a nice way that you can automate it and stand it up, and then regardless of whether it's running on 2 machines or 100 machines or 1,000 machines or 10,000 machines, you can basically scale it up and scale it down however you want. We also provide a network load balancer built in to cloud services, so you can also direct multiple traffic to them. And a cool thing you can do within a cloud service is indicate whether or not the role is healthy or not. And if you say, for example, in a cloud service, I'm having problems, the network load balancer will automatically take you out of rotation and start sending traffic to other ones. And then when you get healthy again, we can add it back. It'll also, as I mentioned this morning in the keynote, if a machine goes down, we can automatically remove it from rotation, spin up a new instance for you, add it back, all automatically. And so this kind of frees you up from having to actually handle all that yourself, and you don't have to worry about getting a page at 3 in the morning that your app is down or having problems. And so if you're looking for a large app that you're deploying or multiple tiers and apps, definitely recommend looking at cloud services. And we'll have some more talks later this week where you can go into more detail on it. So one of the things that hopefully you've seen both with the keynote demos this morning, but also the ones I've done over the last 30 minutes, is kind of this emphasis point that we like to kind of focus on or claim with Azure, which is we kind of want to enable you to focus on your apps and not have to worry as much about the infrastructure. So how do we provide you an environment where as a developer or as an IT pro, you can really kind of get a lot done really, really fast without having to handle a lot of the administrative details, without having to do patching yourself, without having to configure load balancers or network routes yourself. Instead, the programming model and the features we provide help you with that. And I've so far focused this morning on kind of our compute model, so in other words, how you write your own custom code. One of the other things that we provide with Windows Azure then is a number of what we call building blocks. And these are services that we run that are also managed, meaning we're doing the patching, we're doing the high availability for you, that you can then call from within your application. And so I showed this morning media as an example of just one of those services. Dave Campbell showed how you could use the new Hadoop HD instance big data service that we're standing up. There's lots of other cool services that you can also then use within Windows Azure throughout the stack. And I'm going to demo a couple of these ones that we haven't seen so far today as part of it. First one here is a SQL database. And the cool thing we do with Windows Azure is we basically allow you to stand up relational SQL databases in the cloud. They are clustered for high availability, meaning we run them across 3 separate servers. So again, if a machine goes down, you have 2 other instances you can fail over to automatically. And it's fully managed. So we're doing the patching. We're effectively doing a lot of the DBA activity for you. And it provides a lot of great features. So how many people here have ever asked their IT department to stand up a new database? Isn't that a fun process? How long does it take you to create or to ask for and receive a new database? 20 minutes? 20 hours? 20 days? Someone told me 9 months. That was the worst. So one cool thing about Azure, again, is we have this managed service model. I can create databases really easily. Let's walk through how you do it with Azure. So one of the things I can do is, again, hit New. We've seen websites, virtual machines. We talk about mobile services. Let's click Data Services. Let's stand up a new database. What would you like to call it? How about Stevens DB? Could pick a server, or I could just choose a new one here. Go and hit OK. Let's count. 1, 2, 3, 4, 5. Done. We got a new database. 5 seconds. It's probably like 7 seconds since I started late. But anyway, click on it, drill in, and basically I have a database that's ready to be used. And you'll notice, again, consistent UI. One of the things we did this week is we actually updated SQL databases, so we now have a dashboard view, so we'll show you even deadlocks, failed connections, successful connections in real time throughout the portal. I can basically grab a connection string, and we show you how to use it from ADO.NET, ODBC, PHP, and JDBC, and I can start programming against this. That literally was how long it took. You might be asking, okay, but how much did it cost? The cool thing about the model here, again, is you pay only for what you use. And so this database I just created, I think it was a 1 gig database, is under $10 per month to pay for. There's no SQL license that you need to provide, so there's no upfront costs. In this case here, it's a gig. I can use it. If I only use 100 megs, it's actually, I think, $4.99 per month. And this gives me kind of the ability to program. I can create ADO.NET. I can use whatever programming model I want in order to store data in it. And again, at a later point, if I want to size it up, I can go ahead and say, let's make it 150 gigs, hit save. And we're going to do a scaling operation now in this database. We're done. And now I have a 150 gig database that I can dump data into. So it gives you lots of power, lots of flexibility. Again, I'm going to be cheap since it's my own personal credit card and scale it down. Yeah, again, the beauty there is it just kind of works for you. And that's kind of the model we're trying to do with all these managed services, is kind of make it so that it's really easy to take advantage of, really easy to use. You can also go ahead and notice this export button. This is something we introduced recently. One of the things this allows you to do is you can now export your database and save it on blob storage, which also means you can download it, and we use the same backpack format that SQL 2012 uses on premise. So it's a great way that once I do my development, if you want to, you can export it, and you can actually install it on SQL on-prem, or vice versa. You can import and export it directly through here. So just one kind of example of a managed service that you can use. Let's talk about some of the other services we provide. Caching. One of the things that when you're building large-scale apps in the cloud that you have to think about is how do I handle lots of load? And in particular, if you're building services for your company, or if you're an ISV providing services to others, there's going to come a time, if you're really popular, you're going to need to handle a lot of traffic. And one of the key things about that is, to handle that, is to use caching techniques so that you're not having to hit a database each time, and you can basically scale out in a very low latent way. We have a new feature called the dedicated cache. It's actually shipping in final release form this week as part of our new Azure SDK update. Basically provides a low latency in-memory distributed cache. How many people here have used the ASP.NET cache? A lot of people have. The ASP.NET cache is an in-memory cache, but it's tied to a single machine. So in other words, if you stick something in the cache, it's only in that worker role that web app is running. And so if you've got 4 or 5 machines running your website, they're each going to have a separate copy of the cache because it's all in memory. Cool thing about a distributed cache is it's actually shared across the machines. And so if one machine sticks something in the cache, the other one can automatically access it. And the cool thing also about a cache is you can grow it and shrink it dynamically in the same ease of use that I kind of showed earlier here. It also supports high availability, so it's dedicated, so it's distributed, so it can be on multiple machines. If you mark an entry as requiring high availability, we'll make sure that we copy that cache into 2 separate cache servers. So again, if one goes down, you can automatically fail over to the other one. And we support both our own protocols, but we've also, as part of this release, added memcached wire protocol support. So if you've got a client library or an OSS package that uses memcached, you can point it at our cache server and it just works. So let's do a quick demo of that. Just going to open a project here. And a simple little Twitter reader app. And what this does is it just goes out to Twitter and displays a bunch of tweets that are happening on Windows Azure. So if I run this now, go ahead. Oop, nope, I got to run it through here. But go ahead and run this now. It's going to spin up the Windows Azure emulator because I'm running this as a cloud service. Oh, it's a new network, so yep, please do allow that emulator to go through. And this is going to retrieve a bunch of tweets from the internet, and away we go. So 1 second here. Go ahead and hit query. This is going off to Azure or to Twitter, pulling back a bunch of tweets. And you'll notice that it takes about 1.5 seconds to go out to Twitter in order to retrieve those tweets. And so if I'm doing that on every page request, that's going to take a while, longer than I'd like. Continue. That's actually on the client side. That's not a server-side bug. So how do I make this faster? And so one of the things I can do is introduce caching. So instead of going out each time, I want to retrieve the tweets and then cache it using our distributed cache. Cool thing about enabling it, I just go ahead and double-click on this role in my cloud service. There's a new caching tab that we've exposed as part of our dedicated cache. I can click Enable Caching in order to enable caching as part of it. Hit Save. I can then go into my Twitter Reader app. I can use NuGet to install the caching package. And this is just going to install a .NET library that I can program against. I can then go into my Twitter feeder controller. Say that 3 times fast. And I'm just going to replace this code right now, which is always going off to Twitter, with some code like this, which is going to use the cache. And all this is going to do is just creating our cache object model, checking to see whether or not the tweet's already there. If it's not, I then go get the tweet and add it to the cache, and I just return it. So very simple change. And then last but not least, I'm going to go into my web.config file, and I've enabled caching on this apps, which basically automatically added this code into my config file. I can say Twitter reader, like so. I'm going to enable local cache in order to make it even faster. This allows me to use inside my process a microsecond cache, and then it falls back to the distributed cache. And now when I run this application, what I should see is we're spinning up the emulator, we're spinning up the cache, so it's actually simulating a local cache here. Let's save that. For some reason I have a JavaScript error, so let me run without the debugger. Again, that's not a server-side thing, that's a client-side thing. We're going to spin up this emulator. There we go. And what you'll see here is the first time it's going to take a little bit longer, but as I start hitting this page, notice the responsiveness now is under half a millisecond. And this is basically kind of the benefit of now pulling all the data from the distributed cache, and now I can kind of provide back kind of super fast responsiveness to my customers. Cool thing about the way the cache works, again, is it's distributed. And we support two models. The one I just showed here is where I can actually enable the cache on any of my existing roles within my cloud service. This allows me to use the memory on the machines that I'm already paying for, so it doesn't cost me anything in order to enable the cache. We then ring join this distributed cache so that instead of having 300 megs total, we actually have 1.2 gigs if I have 4 instances. Alternatively, if you want, you can actually, inside your cloud service, stand up dedicated worker roles. And I could have, for example, a 24 gig cache that way, and then have my web front ends access it. So the cool thing is you can take advantage of this cache literally for free if you've already got a cloud service, or again, if you want to do even more, you can scale it up. And we have some customers that are running, hundreds of gigabytes of cache. Beauty is the responsiveness, even on the cross machine hop, is basically on average about 1.1 millisecond round trip. So it's super fast, super efficient. And because it plugs into our scaling model, if I decide to scale up the number of workers I have, the cache will dynamically grow in size, and I now have 48 gigs available to me instead of 24, and I can scale that down as well. And so if you remember in the keynote where I showed in the Scale tab, I can scale up and scale down each tier. This plugs in directly to it. It's a great feature you can take advantage of. Another service that we provide that's managed that's really cool is called the Service Bus. This basically gives you secure messaging and relay capabilities, makes it really easy to build hybrid apps, and it allows you to kind of architect your app so that you can run in a more kind of what we call loosely coupled way. And what do I mean by this? Well, as an example, let's say I have a store front end and I have a service in the back end. And every time someone places an order, my front end web server places an order. Well, if I basically do this in a very synchronous kind of way or tightly coupled kind of way, if I have a failure in the back end, I'm going to ultimately bleed out those errors to my customer, and I'm not going to be able to place orders. In a loosely coupled model or a messaging-based model, what you can often do that adds a bunch of resiliency is introduce a concept of a queue. And so now on my front end, instead of directly talking to my back-end service, I can create a message object, stick it in a queue, and then the back-end service can dequeue it and actually do something with it. And the benefit there is if I got a failure in the back end, I can still be pumping messages through into my queue. And then once that back end comes online, I can pull those messages off and I can do stuff with them. So it's kind of standard message-based approach. Other cool thing about this is just from a scaling perspective, it means I can have multiple front ends that are all dumping messages into the queue, and I can have multiple back ends pulling them off. And this gives you kind of a concept we call load leveling, where basically you can have arbitrary numbers of front ends or back ends, and you can, again, scale these up or down based on your traffic within your application. So you're only paying for what you need. So to make this all real, let's go ahead and show this in action. I'm going to do a simple demo. If you have internet access or a phone, break it out because we're going to need your help. Where basically I'm going to have a web app hosted inside Azure, built with MVC4. And this app, when you post to it, is going to create a message object that we're going to stick in what's called a service bus queue. And then I'm going to run an app on my laptop, which is going to just be a simple console app. And I'm going to dequeue whatever you say to me, and I'm going to print it on the screen. This is really exciting and really scary. So be gentle. So how does this work? Well, inside Windows Azure, you saw me create a variety of services. If I want to, I could create another app service. I could create a queue. I just say, hey, whatever, pick it. It would create it, and it would show up inside the portal. And so you can see here, there's a queue right here. I have an orders queue. Basically, what I'm doing inside my app, my web app, is simple ASP.NET app. And all I'm doing is displaying a form. When you enter a form, I basically just get a reference to that queue, create a message, and send it to it, and then redisplay. And so you can actually access this app now by going to what is the URL? Can't remember the URLs. I think it's scottgumessage.cloudapp.net. Let me make that bigger. So if you go to this address, scottgumessage.cloudapp.net, you can see that form, and you can go ahead and you can type me anything. So, hey there. There we go. So anyway, you're sticking it in a queue. Now right now, it's just building up in the queue that I have inside Windows Azure. So I don't have any listeners on it right now. Let's instead now go ahead and open up my queue receiver. So this is a simple command line console app written in C#. It's just connecting to the same queue. It's going to be running on my laptop. And it's just going to loop forever, pull the message off. And if it's not null, it's just going to display it on the screen. And so now, if we go ahead and launch this up, there we go. You can actually see everything that people in the room are saying. Oh, my armpits, thank you. Anyway, you can basically see in real time. Wow, there's a lot of feedback here. You can basically see in real time everything that's going there. And this is a great example of how you can tie together stuff running in the cloud through a web role, firing into a queue, going down to my laptop, displaying. There's a lot of stuff. My guess is there's a big Channel 9 audience watching this, since I don't see that many people typing inside the room. So that's a lot of messages. That's the most I've ever seen. That's awesome. And just like other services inside Windows Azure, I can go to the dashboard, and there's a slight delay here, so I should see it in a few minutes, a huge burst of messages that will show up. So I can also see kind of in real time how my app is doing. So that's one cool feature of the service bus. Let's now show another one. So this is an example of how I can do kind of an asynchronous message-based approach. Other capability we support with Windows Azure is called the relay. And this is useful for cases where you want to do a synchronous approach. So let's say, for example, you got a database inside your organization, or you have an app inside your organization that you're just not comfortable yet moving to the cloud. Your guys say, hey, we've already paid for the hardware, we've already paid for the database, or I don't want to copy it over to someone else's data center. What you can do with the relay, which is pretty cool, Service Bus, is basically build an app and then use WCF to connect to a Service Bus relay running inside Windows Azure. And this allows you to publish a WCF contract to the cloud that your client applications can then go ahead and access. And this provides a secure tunneling approach, and it allows you as an organization to only publish the data you want using well-known contracts that you support. So let's see what this looks like in action. So to try this out, I'm also going to need some help from the audience or people online. I am opening up a WCF project. It's again going to be a command line console app. I have a customer contract defined in WCF with a get customers and get customer ID method. And I'm implementing it using Entity Framework against a local database on my laptop where I just return the data. So very simple contract. I can then, inside my console app, when I start up, connect to Windows Azure, and I'm publishing this service up in the cloud. And I just display some details there. And every time someone connects to it, I actually write a little bit of debug logging data to the screen. And what's cool then is, if I go now in my browser, connect over here. Yep, should see in a second, assuming the network gods are with me. I might also be downloading billions of messages from various people. But I should see, hopefully in a second here. Come on. I wonder if I ran the right thing. There we go. Okay. Oh, and someone's already found it. Great. Oh my God, that's scary. Cool. I didn't even describe what I'm doing yet. So this is an app, again, you can hit. And now I'm getting slammed by thousands of people on the internet, where basically what you should see is like, oh, wow, look, I can actually retrieve the data. Basically, this is hitting my laptop. I think you're actually... I'm getting so many requests that it's actually, yeah, it's... I'm running on a SQL Express, so it's single core, small amount of memory. But everyone out there apparently is getting the data. But basically what this would allow me to do is reach down and connect to that service, hit the data, and retrieve it. And yeah, if I wasn't being slammed by thousands of people, it would work. Cool thing about this is also does load balancing, so if I knew that there were this many excited people that were going to hit that site, I probably would have put a bigger database and I could load balance it. But again, kind of a cool example of what you can do in action here. Last demo for people, if you can keep me online, channel 9 one more time. So this is a great way to make it secure. And the beauty about both these things, you only pay for what you use. And so from a pricing perspective, you're only paying by the message or by the hour. And it's basically you could run a relay 24/7, I think, for an entire month, and it costs about $2. So pretty price effective. Lots of services I showed here that you can take advantage of. These are all built-in ones that we provide. Last thing I'm just going to go talk about briefly is the Windows Azure Store that we announced and showed off earlier in the keynote. Cool thing about it, lets you consume services from a lot of our partners, makes it really easy to try and purchase things, and billing is integrated into your Windows Azure bill. So you don't, if you've already got your bill set up with us.